Hi guys, welcome to Beginner-Techies. In this video, I'm going to discuss about another problem of sliding window technique. Right? I have already solved few problems with the help of sliding window technique. In the last couple of videos, I already discussed about the sliding window approaches, like how can we actually identify whether the given problem is actually applicable for sliding window technique. So this is another problem. The problem name is minimum size subarray sum. This is the Leetcode problem number 209 in the Leetcode. So let us understand what is the problem statement of minimum size subarray sum. Okay, and we will see whether this problem is actually applicable for sliding window technique or not. Okay, so let's jump into the Leetcode itself. Okay, right. So here the problem is given problem number 209, minimum size subarray sum, right? So here given an array of positive integers nums and a positive integer target. Two inputs are given. Return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Okay. So we have, let's understand this example. Okay, so target 7 is given and num array is 2, 3, 1, 2, 4, 3. Okay, and output is 2 here. So let's understand how the output is 2 here. Okay, let me draw this problem into the notepad itself. Okay, right. So we have this problem. Nums is equal to 2, 3, 1, 2, 4, 3, 1, 2, 4, 3, and target is 7 here, and we have to find out the minimal length of a subarray whose sum is greater or equal to target. Minimum length of subarray whose sum greater is equal to target. We have to find out this one. Okay, whose sum is greater is equal to target. So let's visit the array here. So let me add the index here 0, 1, 2, 3, 4, 5. Okay, so what could be the possible combination we can get from this array? So we can get, this is the subarray, sorry, we can get this one as a subarray, and we can get another subarray is 3, 1, 2, 4. We can get another subarray is 1, 2, 4. Okay, and we can get another subarray is 4, 3. So the sum of this subarray is 2 plus 3 plus 1 plus 2, 8, right? The sum of this subarray is 3, 1, 4, 4 to 6, 10. The sum of this subarray is 1, 7, right? And this is 7. 4 plus 3, 7, right? So we need to find out the minimum length of subarray. So here if you see, length is 4, length is 4, length is 3, length is 2. So this is the minimum length of subarray, right? So this will be the output in this case. Output is 2. So we have to find out this. Okay, so there could be multiple combinations of subarray, which so there could be a multiple combination of subarray, but from those subarray, from those combinations, we have to find out the minimum length of subarray. So this is the problem statement, and this is what we have to find out here. Okay, so let's see how can we find out. Nums is equal to 231243, 231243, and target is 7, right? So let's first see whether this problem is applicable for sliding window technique or not. So the first case is, if the problem is given for array string, so this is array problem, the first case is passed. The second case is, are we talking about substring, subsequences, subarray? So yes, we are talking about subarray in this case, right? In the last couple of videos, we have solved few a string problem with the subsequences and substring, and this problem is actually for array. So here we have this term subarray. Okay, so this is also applicable for sliding window. Do we have any window size? Right, so there is no window size, right? Window size is not given. Okay, so we have to find out, because sliding window, in the sliding window technique, we can have fixed or variable. So we will decide dynamically whether, like, what could be the window size. Okay, so out of these three cases, two cases are passed. So we can if two conditions are passed, then we are good to go with sliding window technique. Out of three, if two cases are passed, then we are good for sliding window. Okay, right, at this problem. Okay, two, three, 1, 2, 4, 3. Okay, target is equal to 7. Let's apply the sliding window template here. Okay, so let me create two variables now, and we will maintain one more variable, sum is equal to 0, and another one is min, right? So this will contain max value. Okay, this is just for comparison of window size, like subarray size. Okay, so if you're talking about sliding window technique, then we should maintain one window. So in this case, we will maintain, like, variable size window we have to maintain. So window size will be j minus I plus 1. Our output will always vary. Our output will be depend on this window size. This is important. Okay, so let's see. Initially, we will start from I, and j. J will be increment, and we will update this sum value every time whenever j will increase or whenever I will increase. In that case, we will update this sum value. Okay, so initially it will be 2. Okay, again I is equal to 0, j is equal to 1, sum will be 5, right? I is equal to 0, j is equal to 2, sum will be what? 6. I is equal to 0, j is equal to 3, and sum is equal to 8. So every time we will check whether this sum is greater or equal to target or not. So here it is still less. It is still less. It is still less. But here the sum is greater is equal to what? Target. 7. 7 is the target here, right? Target is 7. So if we found this, then we have to calculate the window size. window size. What is the window size here? So window size is j minus I plus 1. So 3 minus 0 plus 1 is equal to 4, and this will be the min. So min is 4 now. Okay. So we got window size 4 here. So we will increment the I position, and we will remove ith element, ith number from the sum. I will increment. J is what? J is still 3, and sum will become 8 minus 2 is equal to 6. Now I is equal to 1, j is equal to 4, and here sum will become what? 6 plus 4 is equal to 10. So this will be the next subarray, and this will be the next window size I and j, right? 3, 1, 2, 4. Let me write here. This is the next subarray. Okay, so if we calculate this again, we will get what? J minus I plus 1 is equal to what? We will get 4 here, right? We will get 4. 5 minus 1 plus 5 minus 0, 1, 0, 1, 2, 3, 4. So 4 minus 1 plus 1. So again we will get 4, and min is 4. So this will remain as 4, right? Now since this is greater is equal to target 10, so we will again increment the ith position. So in this case I will be 2, j will remain 4, and sum will become what? 10 minus 3, ith position is 2. So we will remove 2. First we will remove 3, then we will increment this ith position. Okay, in every case here itself. Okay, here we have removed this ith position. I mean it was 0, then it will increment as 1. Okay, so let me update here. I is equal to 2, right? So 10 minus 3, 7. Again it is greater is equal to what? 7, target. So in this case window size will be this one, right? 1, 2, 4. Window size will be, if I is equal to 2, j is equal to 4. So window is 1, 2, 4, right? In this case we will get j minus I plus 1 is equal to what? 3, right? This should be 4. Sorry. Right? So 4 minus 2 plus 1. So 3. So this 3 is less than 4, right? So min value will be replaced with 3. With 3. Okay. Now again, if we see, I is sum is equal to 7, right? So this is greater is equal to what? Target. So we have to remove the ith number from this. So I is 2. We will increment j is equal to 5. In this case, sum will become what? 7 plus 3 is equal to 10. Right? which is greater is equal to what? 7 target. And in this case we will calculate j minus I plus 1. So j minus I plus 1 will become, again we will get this window. Which one? 1 2 4 3, right? 1 2 4 3. This window we will get. So in this case, this is again the min size is equal to 4 here in this case, right? Window size is 4. So if we compare 4 and 3, so we will get min as 3, right? Because 3 is lower than 4. 3 is less than 4, right? Sum is equal to 10. So we have to remove the ith position from 10. Okay. So ith position should be removed. So at position number 2, 0 1 2, right? So this is 1. We will increment I. So I will become 3. Again we have to remove this position as well, 2. So sum is equal to 9 minus 2 is equal to 7. Again we have to remove and 9 minus 2 is equal to 7, and I should increment, I will become 4. Okay. So this 7 greater is equal to 7. So in this case, I is equal to 4, j is equal to 5. So window is 4 and 3. In this case, we can get j minus I plus 1, 5 minus 4 plus 1. So it should be 2. So this is the final output from this input. Okay. So this way we can build our logic, right? So let's write the code into the Leetcode. So right, I'm just defining the variables. We have discussed this sum as well. We should also require. We need this min for result. Integer dot max underscore value. Okay, right. So as per the sliding window template, usually I use this one while loop. So we should start from j is equal to 0, say nums dot length, right? Right. Here we will calculate what? Sum of nums of what? J. So every time sum will be adding jth element will be adding into the sum. Okay. So here we will compare with target, right? So if it is greater is equal to, then we can simply find out the mat dot min. So min and j minus I plus 1. This is our window size, right? Okay, fine. Right. Once we got this min, so what we are doing? We are removing the ith element from what? From this sum, right? So here we will remove sum is equal to sum minus nums of ith element, right? And will increment I plus plus. Okay, right. So if this sum is still greater is equal to target If this sum is still greater or equal to target, so what we are doing, we have to remove some nums of I and I plus plus. Here we will increment j plus plus. Okay, so here in the problem statement it is given if there is no such subarray, return 0 instead. So if there is no subarray, then we have to return 0. So in this case we have to maintain one boolean variable here. Is subarray exist? Is subarray exists is equal to false. Okay, so this should be updated here. This should be true, right? So here is subarray exist, then what? Min, else 0. Let me run this problem. Okay, wrong answer. What is the issue? Output 3. Okay, okay, sum greater is equal to target. We are calculating min over here. Again it will be changed. Okay, so again it will be changed. We need to add the same condition over here. Min j minus I plus 1. Okay, let's see. Oh, I missed this colon. Right, so these 3 test cases are passed. Let me submit this solution. Right, so here we got the result in 2ms optimized solution, and we get it through sliding window technique. There are several other techniques we can apply into this problem and get the result. In this video our main focus is to get the solution in sliding window technique, right? So here if we go through the problem statement here, there is one follow-up, like if you have figured out the O of n solution, try coding n the solution with the time complexities O of n log n. So we can try with n log n approach, but here in this problem we have actually gone through this O of n approach, which is a sliding window technique. Okay, so we follow up if you have figured out the O of n solution. So we have already figured out O of n solution, right? We can try it with n log n, but in this video the main agenda is to get the solution in O of n with sliding window technique.